Good morning, afternoon, or evening to everyone. My name is Behshad Eliari, and today we will be exploring probability distributions, focusing on both discrete and continuous distributions, their real-life applications, and how to calculate them using Excel. Okay, let's begin. So, in this presentation, we are going to cover discrete distributions and their distributions, like the binomial distribution and its definitions. Um, I'm going to mostly focus on binomial on this presentation. Uh, Next, we're going to see the real-life examples of these distributions. Then we're going to calculate them in Excel. Then we have continuous distributions such as normal and exponential and their importance. And finally, we will conclude with key takeaways. These will help us understand how the distributions apply to engineering and everyday problems. So, discrete distributions, what are they? Well, discrete distributions apply to discrete random variables that take specific countable values, as we can see here. Uh, we have some examples for them, such as the number of defective products in a batch, or the number of successes in repeated trials. Uh, we have some common discrete distributions such as binomial and negative binomial, which is basically the success or failure trials. We also have geometric, hypergeometric, and Poisson. So, uh, for example, geometric is the time until the first success, or Poisson is events in fixed intervals, like call center traffic. These are foundational for quality control, risk assessment, and many more. All right, let's talk about real-life examples of discrete distributions. Let's make this concrete. Binomial means, imagine testing 100 light bulbs for defects. Each bulb either passes or fails. The binomial distribution helps predict how many will pass. This is basically the usage for binomial. Or for example, for a person, a call center gets an average of 50 calls per hour. The Poisson distribution estimates the probability of receiving 60 calls in the next hour. These tools are everywhere, from manufacturing to service industries. And how do we calculate them using Excel? Excel simplifies these calculations. For binomial, we can use equal sign binom dot dist, and we have to open two brackets. So inside our brackets, we have to include k, n, p, and cumulative. So cumulative in Excel is either true or false. Our cumulative is basically our CDF. And for example, we have a equal sign binom distribution 5, 10, 0.5 false. This will calculate the probability of exactly 5 successes in 10 trials with a 50% success rate. For Poisson, we can use equal sign Poisson.dist open brackets x mean and cumulative. We can demo this later if time allows us. For now, let's continue. Next, we're going to talk about what are binomial distributions. Well, binomial distribution model has a fixed trial, such as n, that each with success probability, which we call p. These key features include outcomes, which means the success and failure only. And we also have the shape, that it is symmetric if p equals 0.5, or it will look skewed otherwise. An example could be flipping a coin 10 times. The probability of exactly 6 hits, that's binomial. Well, what is the practical application for binomial distributions? So engineers use this for either quality control, such as testing a sample of products, or survey analysis, which is estimating voter preferences. It's a powerhouse for decision making with limited data. How do we calculate binomial distributions using Excel? Okay, let's say we have 20 trials. Success probability is 0.3% and want the chance of less than or equal to 4 successes. So in Excel, in order to write this, we would write equal sign binom.dist, open brackets, and inside we have 4, which is our chances of successes, or also known as X, and we have 20, which is 20 trials. And then we have the probability, which is 0.3, and the cumulative, which is true. This will give us the cumulative probability. We can change true to false for exact probabilities. Now let's talk about continuous distributions. So continuous distributions apply to measurable data like time, weight, or temperature. Unlike discrete, these variables can take any value in a range. For example, we have normal, exponential, gamma, or uniform. These contribution distributions, each of them do their own tasks. For example, normal continuous distributions are used for heights or test scores, or exponential distributions are used for the time between machine failures. These are essential for modeling real-world variability. Now let's talk about some real-life examples of continuous distributions. So I'm going to use normal distribution. We want to find the SAT scores clustered around the mean or a bell curve. Or for exponential distribution, we can use the time until a light bulb burns out. Just understanding these things helps predict outcomes and manage uncertainty. Now, how can we calculate such distributions using Excel? So in Excel, for normal distributions, we have norm.distribution or dist, which we have to have a bracket that we will fill with x, mean, or for example, if we want to go with the students, we can use std div or cumulative. Or for exponential, we can have equal sign expon dot dist, and we have x, lambda, and cumulative to fill inside. For example, we want to find a probability that a value is 75 or lower in a normal distribution, and our mean is 7 and our standard deviation is 10. So for normal, in order to write this in Excel, we have to write equal sign norm dot dist, and inside will be 75, 70, 10, and true. I'm sorry for earlier. I said student dev, which wasn't right. I got that wrong. It was actually standard deviation. Yeah. All right, let's talk about normal distributions. So normal distributions, or also known as Gaussian, are symmetric and bell-shaped. It is very important because of the central limit theorem. The central limit theorem basically says that the sums of random variables tend to be normal regardless of their original distribution. This makes it a cornerstone of statistics. Now let's talk about the applications of normal distribution in real life. For example, we can use the normal application on quality control, such as monitoring product dimensions, or finance, which we can use it for modeling stock returns. It is the gold standard for analyzing data variability. Now, what are the Excel tools for normal distributions in Excel. So we can either use norm.dist or we could also use norm.env, which we can use to find percentiles, such as what's the score marked to the top 10%. Or we can use norm.s.dist, which is for standard normal, which means that we have a mean of 0 and a standard deviation of 1. These are indispensable for data analysis. And now let's talk about exponential distribution. Exponential distribution models time between events, such as machine failures. The key property of exponential distributions are that they are memoryless, which basically means that the next event's timing doesn't depend on past events. For example, if a machine fails every 5 years on average, the probability it fails in the next year is the same, no matter how old it is. Now, what are the usage scenarios in real life for exponential distribution? Well, engineers can use it for reliability analysis, which is for predicting equipment lifespan. Or we could use it for queuing models, such as estimating customer wait times. It is all about time to event problems. Now, let's implement exponential inside Excel. We can use the equal sign expon.dist and we open a bracket and inside we have to use x, lambda, and cumulative. For example, we can say if events occur every 2 hours, which our lambda would equal to 0.5, the probability the next event happens within 1 hour is expon.dist inside the bracket 1, 0.5, and true. Now let's go to the conclusions. So to wrap up, we learned what discrete distributions are, such as binomial, which are basically for count successes or failures. We also learned what continuous distributions are, such as normal or exponential. These models are used for measuring data. And we also learned that Excel can be used to calculate such data. Excel is basically a very powerful tool for calculation. Mastering these will help engineers analyze data, predict outcomes, and make informed decisions. Thank you for listening. Also, I wanted to show you my continuous and discrete examples in Excel. So let's continue and start with discrete. For example, I made several versions of discrete distributions. Let's start with binomial. So what is happening here? We have a question right here. What is the probability of getting exactly 3 heads in 5 coin tosses? So from this question, we can extract these information. Trials, which is 5, or also known as our n, successes, or x, which equals to 3, and the probability of head, which is our p, equals 0.5. Now, as I mentioned earlier, we can use this formula right here inside of our Excel format to get the amount or our result. So for 0 number of heads, our result would be 0.03125. The answer for this question is actually 3 because we have 3 of the same numbers, as you can see right here. So it's for 2, 3, and 5 would be 0.3125. Another example we could use for Poisson or Poisson. The question asks, a shop receives an average of 4 customers every 10 minutes. What is the probability that exactly 2 customers arrive in a 10-minute period? So we can extract that x equals to 0 to 8, which are our number of arrivals. And our mean, also known as lambda, is our 4. So we have 0 to 8 customers, And we need to calculate the result of this question. We can use it using this formula. We can use this formula such as Poisson.test, and we can calculate the result inside of this cell. We could also try geometric, hypergeometric, or negative binomial. I'm just going to go through them very fast. This question asks, the probability of success in each trial is 0.3. What is the probability that the first success occurs on the fourth trial? So our x equals to 1 through 6, and our p is 0.3. So we have 1 to 6, and we also need the formula for it. Now the formula for Poisson, geometric, doesn't exactly exist in newer versions of Excel. That's a problem. So in order to actually get an answer, we need to create our own formula using the real-life formula of Poisson. And with using that, we can get these results. Now let's talk about some continuous distributions. So right here, we have a question for continuous distribution exponential. Let's say we want to find the average time between buses, which is 10 minutes, and the lambda is 0.1. We need to find the probability that the bus arrives between 5, 8, and 12 minutes. So what I have done is that I created a cell called lambda, which equals to 0.1. We also have these lengths, 5, 8, and 12. So the Excel formula for exponential distributions is as it follows. So we need to get to this number. So we're going to put the first number, our x, then we're going to have 0.1, and the CDF is going to be true, so the answer would be this number. Now we can do this for all of the given x's and calculate their probabilities. Or we could, let's talk about normal. So, normal. A machine produces parts with lengths normally distributed with mean 100 millimeters and standard deviation of 5 millimeters. Find the probability that a part is less than or equal to 95 millimeters, 100 millimeters, and 105 millimeters. So I've extracted these informations from the question. We have 95, 100, and 105, which is our x. We also have the mean, which is 100 millimeters. We also have the standard deviation, which is given to us as 5 millimeters. So this is very simple. All we need to do is the first x, which is 95, and a comma. We also need the mean, which is 100, and comma, the standard deviation, comma, CDF, which is true. And the answer would equal to this number. So we have calculated for 95, 100, and 105. I could also show you another one such as uniform. This is also another common type of distribution. So a machine cuts rods with a length of between 10 centimeters and 20 centimeters. What's the CDF and PDF at lengths 10, 12, 15, 18, and 20 respectively? So we have our x's which start from 10 until 20. So 10, 12, 15, 18, and 20. We also have a 10 centimeter and a 20 centimeter. These are going to be our minimum and maximum points. So in order to find the CDF and PDF, all we need to do is to use this formula. So the first formula for CDF is we need the x, our first x, minus our minimum, which is 10. Then we are going to also have 20, which is our maximum, we're going to subtract that with our first x. And then these two will be divided by each other. And the result will be given to us. So as you can see right here, the CDF was given to us, which is 0. We can do this for all of them. And in order to find the PDF, which is very simple, all we need to do is divide 1 over 20 minus 10, which is our maximum, or our B minus A, which would equal to 0.1. This is the same for each of these questions. Of course, I have many more, such as gamma, but I haven't explained this in the PDF or the PowerPoint, but we can go through it really fast. So gamma has its own formula in Excel, which is gamma dist. And the question asks us, the task completion time follows gamma with shape k equals 3 and scale, which is our theta, equals 2. Find the probability task takes less than or equal to 3, 5, and 7. So we have our x's, we have our formula, and we have our k and theta. So for gamma, we only need to first have our x, then our k, then our theta, and then our CDF, which is true. Then this answer will be given to us. These are the probabilities for each. I think that's enough for continuous. Maybe I want to go back to discrete and maybe talk about negative binomial. So negative binomial is basically the chances of failures. So what is the probability of having X failures before achieving 3 successes if the probability of success on each trial is 0.4? So our number of successes are 3, probability of success is 0.4, and X is the number of failures before. So we have 0, 2, and 4. And then we have the negative binomial for in Excel. The formula is negbinom.dist. So this is negative binom distribution, which will be our first number, which is number of heads, and then it's going to be 3, which is our R, then 0.4, which is our P, and then the answer will be given to us. We can also check out hypergeometric, which is, let's say a box has 10 red and 15 blue marbles, which in total are 25. If you randomly select 5 marbles, what's the probability that exactly 2 are red? So we can use our n, which is the population size and is 25 in total. We also have the number of red marbles, which in total are 10, and the sample size, which was given to us, was 5. And our x, which is the number of red marbles, are 2. So we have 0 to 5, which are the trial numbers. Then we have the formula for hypergeometric distributions. So the formula is hypgeom.distribution. And inside, all we need to fill out is first our x, then our 5, which is going to be the sample size, or n, 10, which is going to be our k, and 25, which will be our n, which is capital. And then we have the cumulative, which is false, and it will give us these answers. So that's it for today's video, and I hope that you enjoy and have a good day.